into the YEESI Lab training in the course Machine Learning in Agriculture. So in the previous video, we actually did discuss the basics and the introduction of machine learning. So it's my hope now, to this moment, you understand what actually machine learning is and where you can apply it, and you can solve some real-life scenarios, at least in theory, using machine learning. So in today's video, we're going to actually put our hands on practices. We're going to do some practicals, actually some programming, which I believe is the most exciting part of machine learning, at least my most exciting part. And I just want you to understand now, we're going to use some of the data sets from the scikit-learn. So scikit-learn is actually a machine learning repository. It's on free and open source. It has so many libraries for Python, for machine learning. It's so rich and powerful. So you can just go to the website. This one you see here. You see some classification tasks and some algorithms and the application where you can use it, the regression algorithms and the clustering. It is very, very powerful. So I recommend that you use it. So they are going to see some practicals on how to actually use it. Now, before going to the practicals, I believe that you have an understanding of what, Jupyter Hub is. This Jupyter Hub, if you have a Jupyter Notebook or a Google Colab, anything similar will work. And if you don't, please just go back to the video from Dr. Telemala that shows how to use Python in programming, because Python programming is essential if you're going to use machine learning. It is very, very powerful. So if you're new to programming, I would recommend you first begin with the videos introduction to Python for machine learning from Dr. Telemala, and then you guys proceed with these videos. Okay. Now, the data sets. As we spoke earlier, the data sets we're going to use today is from the scikit-learn built-in data sets. But you can also find them in the UCI website here. You see a lot of data sets. For example, iris, you have adult, you have wine. So if you want to understand any of these data sets, just click on them. If you just click here, it will just take you to this iris data set here. Now you can actually download the data sets. If I click this data folder here, I'll download the data and the description is here. So if you want to understand what this data is and what the problem is and what does it contain, just check on the description here. Okay, so just in brief, the iris dataset, before going further, the iris datasets, I just Google the image here. This, it is like this. Iris is actually a flower, okay? It is a flower and it is a classification problem, as we spoke earlier. Now, the aim here is to actually classify one of these iris, species into 3 categories or 3 classes. The first one is called Iris setosa, and then you have Iris versicolor and Iris virginica. Okay, so you're going to judge and classify these, flowers or these species, iris species, into one of those categories, as I mentioned, based on their petals and their sepals. Okay, so for each sepal, for each observation, we have the sepal length, which is the distance from here to here of the sepal, and the width of the sepal. Okay, and the same applies to the petal. You have the length of the petal and then the petal width. Okay, so you have 4 attributes: sepal length and width, and then petal length and width. Okay, so let's just dive in here into the coding part. All right, so the first thing you're going to do is, as I told you, you can either download the datasets direct from the UCI repository, or you can just load them from the scikit-learn, because iris and among other datasets are also loaded from the scikit datasets. The scikit-learn datasets. So I'll just import dataset modules, because in our case, we're going to load them from the scikit-learn datasets. Okay, so from sklearn.datasets, import load iris. This is actually an iris dataset. If you just run it, it works fine. Okay, but also not only iris. For our case, we're going to use iris in this video, but you can download some. You can import some other dataset modules. For instance, from the same package, import load digits. Okay, you can also import datasets. You can import load breast cancer. As I mentioned, there are so many data sets in this built-in from the scikit-learn. For our case, we're going to use, the iris data sets today, but just remember that whatever I'm doing with these iris data sets, you can also do with the rest of the data sets. You can do with the low digits, the breast cancer as well. So I expect at the end of this video, you should be able to replicate, and it should be a homework for you to just continue do on your own what I just did with the iris data sets, okay? So for now, as I tell you in this video, we're going to learn how to use the scikit-learn built-in data sets and just manipulate them, analyzing them, and use some of the scikit-learn built-in classifiers to classify these data, okay? All right, so the first step, the second step is going to be assigning data sets into objects. Actually, these are bunch objects, okay? So I assigned you into a bunch object. So for instance, I'll just create any object. I use iris so that it just goes, consistently. Iris, use the load iris function, just call the function, okay? So as I told you, this is an object I created. You can use any name. It doesn't have to use iris just because I use iris, okay? But for me, for you to understand, because I want you to remember and understand with ease, that's why I just use this name. So for now, we are loading all these data sets. We're calling this function and we are assigning data sets into this object. And this actually is a bunch object. And if you want to understand that, you can just print the type, okay? You can print the type, just check the type for this iris object. If you click here, you run, it will show you that it comes from a class scaling utils, a bunch. So this is actually a bunch object, okay? All right, so we can proceed with the rest of the data sets, okay? For digits, just say you can just go, you can use digits, for instance, like this, and they say load digits. Basically, sklearn has a very good uniformity in terms of manipulating data. So whatever you do with this data set, you can do with the rest of the data sets. Then you can proceed with the cancer. Maybe I'll just call it cancer. That's okay. In the cancer, I can say just load breast cancer, like this. Okay, just make sure you run. So you have any errors? No. Okay, that's good. That's good. So if you repeat to check the type for the rest of digits and cancer, you just do that. It's still a bunch object. Okay. All right. Oh, so now the next step is, let's see and analyze how this iris dataset looks like. Okay. So the first one, okay, I'll just say analyzing iris datasets. Okay. So the first thing is you're going to print. You can print the dir function. If you just call it, it just gives you the attributes of an object. Okay. So if I pass in the name of the object is iris and run it, it will just tell me these are the descriptions. Okay. So it has my data. The first thing is the description. You have the data module, feature names, file name, data. So this is actually what my data set contains. And not only this, like in most of the scikit-learn data sets, they have some things in common, especially the data, the description, the data, and the targets. These are very, very important, okay? And the features, okay? So for instance, if you want to see what is the data? Now remember that as far as you're using sklearn, okay, the data, this one here, and the target is the most important things, simply because your data, these are the observations, okay? These are the features, okay? And these features here, and these targets are the labels, okay? So let me show you real quick. I'll say print. I like to use the print function. You can just not use it. Just depends on how you feel like doing it. So I'll say print iris.data, okay? And then I run this cell. Okay, so you see, you have a bunch of numbers. So for now, maybe you may not understand what they mean, but actually, in this data, you have the first number, the second number, third number, and the fourth number, okay? So these four numbers for data, these are the features of your data, the features. And for the case of iris, as I told you, this one is the sepal length, this one is the sepal width, this is the petal length and the petal width, okay? If you want to know how many numbers are there, just ask for the shape of that. So maybe I'll just just display something here just before here. Okay, I'll say print the shape iris dot data, the shape for iris dot data. So we'll say iris dot shape. If I run it here, it tells me this is the answer. Okay, you just say you have 150 rows and 4 columns. Exactly. So it's the shape of this iris of this data, iris dot data. It means you have 1, 2, 3. If you count these rows, they'll just add up to 150 rows. And each of them has 4 columns, exactly what you see here. Okay, and these columns, you can just see they are the feature names. They are the feature what names. If you want to see the name of these columns, all right, I'll just come here. In here, I'll just add another cell so that you see. I'll say print. Okay, iris dot feature names. All right. Our feature names. Okay, so you have the sepal length, as I told you, the sepal width, the petal length, and the petal width. So 5.1 is actually the sepal length in centimeter, and as it follows, and like I just say here. All right. Now, that was the data, right? So this is the data part, and these are, you have the target. The target is also very important. Now, the target is actually our labels. These are our classes. Okay, so these classes, so for instance, let me just go back here. Let me show you what I mean by this. If I come here, I'll just print, okay, iris dot target. Boom, you have 1, 2, 3. These are actually 150 with 50 zeros, 50 ones, okay, and then 52s. All right, these are the classes. These are the 3 target classes, okay? So it tells you that, for now, it's not very clear. I'll try to make it clear a little bit later. So in a nutshell is, you have 5.1 centimeter, okay? This is the first observation. So because these are also called observations, okay, or rows. So this observation, you have 5.1 centimeter, you have 3.25 centimeter, you have 1.4 centimeter, 0.2 centimeter. After giving all these dimensions for the sepal and the petals, it tells you that the first target is a 0. So I mean, this actually, the first observation is a 0. You understand? And the 0 stands for class setosa. If you just come here and you maybe print, okay, target names, or iris, sorry, print iris dot target names. Let me run this cell. Okay, it tells you the first target is a setosa, versicolor, and virginica, which means instead of writing 0, because we are going to manipulate, we're not writing setosa, we're writing a 0. So it means class 0 is a class setosa. So you have, in your observations, 150 observations, you have 50 setosa, you have 50 iris versicolors, and 50 iris virginica, okay? And this tells you that the first one, 5.1, corresponds to, I mean, the 5.1, this one corresponds to a 0. And some random here corresponds to a 1, whatever, right? So the first 50, you have the 50 observations, they corresponds to setosa, and the second 50 observations corresponds to versicolor, and the third one corresponds to virginica, okay? That adds up to 150 observations, okay. So this is nice, but for now, I'll just hide this because it's taking too much of my space already, and I don't want that. Okay, so this is actually fine. Okay, so I just told you once more, if you want to do the same, you can do the same for digits. Just do the same for digits, analyze what it contains, the number of features that it has, and what are these features standing for, and everything. Okay, and if you want to see the shape of this one, target, you can also come here and print, okay, print iris dot target, dot shape so that you see the shape, okay, the number of rows and columns. It tells you have 150, okay? So 150, it means a total of these, but these are rows. You don't have any columns. Okay, it's just a single column anyway, so it just says 150. You understand it's a single column. Okay, all right. Now, something useful I might want to show you. We can, because, okay, so for scikit-learn, usually the data is the important part because you're going to manipulate the data and check the targets. So the task here is to actually make sure that this, we're training our model so that the next time we give it a different feature, it can classify whether it's a setosa, a vesicular, and a virginica, okay? But remember that the built-in data sets, from the scikit-learn, or if you just find them from the UCI, most of the data, they have been reshaped already, they have been pre-processed. It means they're not noisy, okay? But in your project, you might run into data that is not as smooth as this one. So you have to make sure that you see if you have, missing values. You have so many things to fix if you have some irregularities and everything, okay? Yeah, but for the sake of this video, just understand this is how the data sets look like and then what you can do with the data, all right? Now, let's see the type of the data first. So if I come here, or if I want to print, maybe I can print, the iris.data, the type, sorry. I want to say the type for iris.data. If I print it, it says it's a NumPy, okay? Yeah, this is a NumPy, and more scikit-learn data just showed in NumPy, okay? If I print the target for scikit-learn, it has to be NumPy as well. Target. Okay, perfect. Should be NumPy. Now, what you're going to do here, I want to show you, maybe with this data, we can show them in a tabular form, or we're going to convert them into pandas. And if you don't know what pandas is for now, just understand, okay, it's a data structure. It's a very good and useful data structure, and we'll just cover it in the next videos. But today I'm just going to use a bit part of it. So I'm going to import pandas here. Okay, I said importing dataset modules, but I'm also importing something else. I'm just putting it there. So import pandas is PD, and then import NumPy as NP. Okay, run it. Okay, so we're using this built-in, variable names, object names, but you can change, but these are just standard. So just prefer to not just use the default standards. All right, you can choose, you can change as well if you like. Now the aim here is to convert our data sets in and see if you can visualize them in a different way. So I'll say my data, this is just an object again. I'm dealing with the iris on my data, PD data frame. I'll call the data frame function from pandas. Okay, so make sure you have imported panda before doing this. And then I'll just use NP. Okay. Sorry. Concatenate. I'll concatenate. I'll concatenate the data, the data part, which is iris. The data. Okay. The target. I'm going to concatenate. Okay, just put this. Okay. Run this on P. Concatenate is not defined. Okay, what is this? Oh, sorry. What is this? Sorry. It should be. Okay, so this NP is actually a concatenator function from the NumPy. This one should work. Yeah, it just works. So with this, data frame, I'm just converting, this NumPy, I just concatenate these two columns. The iris.data and the iris.target, which means I'm concatenating the data, the ones that I showed you, the sepals and everything, and then the target. Okay, so now they just become the pandas, so I can use some of the pandas, built-in functions to display it. So I can just say my data dot head. Okay, just put this here. Run it. Okay. Yeah, this one. So this tells you that by default, my data head, it gives you the first 5 observations. Okay, I can just change it just to 10. It will just give me the first 10 observations. So this is just a way of seeing my data into a tabular form. That's what I did here. So the first one was 5.1. If I scroll back up here and I want to uncomment something, the part where I displayed the iris.data. If I don't, then I have to print it again. Where is it? Iris.data, did I? Oh, this one here, just found it. Okay. Displayed, yeah. So now I just concatenated, this part here, which is the data, which is this one here, okay? And then we have 4 features, and for every feature, what is the target? That is exactly what I'm showing here, okay? So I'll just go back here, hide it again, yeah, just save some space. All right, so what I did here, okay, with this one is changing because at the first they were numpys. So if it's a numpy, I can't use this, head method. So that's why I had to change them into pandas and see them in clear. All right, so it tells you that 5.1 centimeter sepal length and 3.5 centimeter sepal width, 1.4 centimeter sepal length, 0.2 centimeter petal width. Sorry, this was petal length. Corresponds to a class 0, which is actually a class iris setosa. Okay, and as I told you, the first 50 observations will fall in class 0, which is a setosa. If I want to see the difference, maybe I can display 51. All right, if I display 51 here, it means I'll see the first 50, like this one here, the old one, but okay. This one, number 51, because it starts from 0. So this makes it number 51. It's actually a different class. And then this is how this data set actually looks like, okay? So I believe now you understand how you can play and manipulate and analyze any data file that you have using these, different methods that we have shown. And if you want to display them in a pandas like this, it is okay. You can just see and analyze it. Okay, so I'll just go to the default 5. So I save space and boom, works. So from now, we can actually classify. Okay, we can train, we can call our classifier and then train it. Then we can see how it can classify the incoming features. Okay, so import, okay, from scikit-learn. Okay, the first one I'm going, oh, sorry. Importing the classifiers, okay. So the first one I'm going to use the k nearest neighbor classifier from scikit-learn dot neighbors. From scikit-learn dot neighbors, I'm going to import k nearest neighbors. K-neighbors classifier, like this one. Boom. Okay, works. All right. And then we can also import from scikit-learn dot. We can use, I mean, maybe linear model. We can import logistic regression. Okay. Run severe errors. Oh, something is wrong. So if you're a programmer, don't worry about the errors. Okay, just see how you can actually solve them, remove them. Okay, module scaling linear. Well, okay, it was a typo. So okay, linear model should be written like this one. Linear model, then run it. Okay, linear. So also another typo. Sorry. Okay, it's good. One thing I just tell you that if you're a new programmer, make sure that you don't write so many lines before running them. Okay, just write one line at a time, then you run. Because if you just get so many errors because you have written so many lines, you don't even know where to begin from, right? Because you have maybe the error comes from the line that you wrote, maybe line number 10, okay, and then you're like in 100 lines, so you have so many errors you don't even know where to begin. It just frustrates you because dealing with errors sometimes can be very troublesome. Okay, something simple like this can take you like hours to figure out what went wrong. Okay, so for now, for the sake of this tutorial, just use these classifiers, k-nearest neighbors and the logistic regression. Remember that this is actually a classification task, because you're going to classify whether it is from this, I mean, category or that category. Okay, so k-nearest neighbors and logistic regression. So now I'm going to instantiate this class Kenyan, and then Kenyan. So I'll create an instance of Kenyan. Next time I'm using it, I don't have to mention this whole class. I'll just use this Kenyan object that I created. It's called the instantiating class. So Kenyan is neighbors classifier. Okay, run. This works fine. Now remember, what k-nearest neighbor does is actually, it is classifying an item based on the nearest neighbors, okay? And covering the scope, I mean, the how k-name works is actually beyond the scope of this lecture, of this tutorial. So I just want to tell you that if you want to see how it works, go to the scikit-learn, or just go to, I mean, just Google, just find a way that the mathematics part and everything that it works. But right now, all you should know is the KNN classifier actually has to have neighbors. So you're going to be classified into the class that you belong. It depends on the number of neighbors that you're in with, okay? So for instance, I have 5 neighbors, and in these 5 neighbors, maybe 3 come from class Setosa, and 1 comes from class Virginica, and nobody comes from another class. It means I have the highest number of neighbors coming from this class, so I probably belong to this class, okay? The theory part of it. Now, you have to specify a number of neighbors, because if you don't, it will just put the default values, okay? So we can just say the k neighbors. I'll just say, because by default it is 5, so I'll put 3, okay? So this can be okay. You can just run, see it's okay. But also you can add some other parameters, for instance, the distance. So with KNN, you have actually 4 kind of distances, okay? 3 main mostly used, but you can have Euclidean distance. Okay, so the metric you're using here, distance, it can be any. It can be Euclidean, it can be Manhattan. I can just say Manhattan distance. Okay, it can be Euclidean distance, Manhattan, Minkowski. Yes, it depends. All right. Okay, so in my case, I can just use this. All right. Now the next thing I'm going to do here is to actually fit my model. I say knn.fit. Let's call the fit method. Now here, you have to be very careful. You're fitting the model. This is actually the part when you're training your model, okay? Now, when you're training your model, remember that you're going to fit the training data sets. Understand? Now, in our case, we have 150 instances of this, okay? So it tells you that now you can put here iris.data, which means it is all this data from here to here, okay? So from here to here, but if I say iris.data, it means I'm putting all those 4 features, which is okay. But for the rest of the data, like 100 instances, I'm putting all 100 instances in my model. This is likely to cause overfitting, so don't use this. Iris.target. You don't do, if you do this like here, as I mean, for this case, it means I'm taking all my data, I'm putting them in a training data set. This is not a good way to do it, okay? You have to split your data actually. And there are different ways. You can select maybe a portion here to do that. You can just, there are different ways to do that. But in this case, we're going to use the train test split. I'm not going to delete this. I'll just put it here. I'll uncomment it and say it's not recommended, okay? Just don't do it, but it is just fine. So in our case, I'm going to do the splitting. So I'm going to import it from scikit-learn, okay, dot model selection, okay, import train test split, okay, should work. Yes, fine. So what this then does, it just gives the train test split function, which has the ability to split our data. So here, I'll just add another cell and say, I'm going to split the data into the testing, in the training and the testing part, like this, okay? X train, comma, X test, Y train, comma, Y test equals to train test split. Now, remember one thing here. What I just did here is, this is the data set, okay? Only 5 instances, but imagine you have all the rest of 150, like from 0 to 149, okay? So it tells you that the X is from here to here, the data part, not the target part, okay? So X test, it means from here to some instance, I'll just choose maybe the first, maybe 80 rows, okay? I'm going to use these for training. I'm going to train my model with this part first. And the part below is going to be X, but for testing, okay? It has nothing to do with the Y, remember. The Y is this part, okay? So you can see in most reference books, they're using Y, a small capital Y. I mean a small letter Y. It tells you that X is a matrix, but Y is a vector. So this one is actually one vector, okay? This, the target part, while this data part is actually a matrix, okay? So I'm telling you that even from these answers here, I'm going to use the specific X train corresponds to their Y trains. So if this one is going to be an X train, it's going to be a Y train, okay? And if this is going to be an X test, it is going to be the Y test. So I'm going to split, like I'm splitting them data, for instance, in a specific, okay, let me specify. Okay, after this one, just say, from iris.data, comma iris, which is the whole data, dot target, which is the whole target. Okay, so X comes from here, Y comes from here. This is actually what it means. So split these X train X test from iris.data and split the Y train and Y test from the iris target, okay? You have to specify the percentage. So test size equals to, I'll just say 0.2%. This is 0.2, sorry, which makes it a 20%. So it means the 20% of this data, okay, will be used for testing, but the rest will be used for training. But the training and the testing, they are both, I mean, the training and testing, they're both divided into 2. So I'll just come here. Okay, see if you have any errors. Boom, no errors. Okay, so I'll come here, I say knn.fit, the best way to do it now, apart from the previous one, I'll say, I'll put X train now. So remember the first I said iris.data, this part, remember? It's going to be X train and Y train. It means the X train and Y train, these are the, I mean, the first, if you just cut the data into maybe 0.2%, as you said. So the 80% of the data, the X and the Y's, I'm going to put them in that mode because these are the answers for these features, like the first feature with this answer, the first, okay? I'm just going in details because I believe some people maybe don't understand this part. So that's why I'm just putting some stress into it, okay? So for now, we have actually trained our data using 80% for training data, okay? And 0% will be for testing data. All right, I'm just fitting them into a model and this is okay. Now, let me see some prediction, okay? The prediction, you can just, okay, this one actually fit function is an, or fit method is an inline method or inline function. I mean, in place, sorry. So it doesn't return anything. So yeah, I'll just say the prediction. I say KNN predict. Okay, this is just a variable, just so that I'm going to be predicting a KNN model. Then use KNN dot predict. What are you predicting now? You are predicting the remaining of the data, which is the X, okay? Not the Y's, it's the X, you see? And then run your model. So this part here fits the data into a model, it trains, and this one is testing our model. And this is very, very fine at this moment. Okay, let's see the performance of this model. Okay, you can measure the performance using different metrics. You can have the confusion matrix. I mean, the confusion matrix we have not covered here. We'll cover it a little bit later as we proceed on. But for now, it is just okay. You can use that one. Just use a classification accuracy. You can just see how it works. For instance, if we use classification accuracy, we say, okay, measuring model performance. I'll say from scikit-learn, sklearn dot metrics, import accuracy score. Okay, yeah, you can have accuracy score, precision score, recall score. These are also members from the confusion matrix. So the accuracy, if we import the accuracy here, we can say, okay, accuracy of this model, I mean, okay, we're checking the accuracy score. But accuracy score for what? For this model here. So just say put a Y test, which is the remaining of the answers from the target, and then put the predicted model here. Okay, and then pred. Yeah, okay, see if I have any errors. So it tells you that our model is accurate 93%. Okay, so accuracy, you can always improve it, and the higher is always the better. Just make sure that you avoid overfitting like we just did there by splitting them. You can also use what we say cross-validation. It will be covered in another video. But here, what we did is very simple. We can just say this is the accuracy. We can print it actually. We can print the accuracy. We can say the accuracy of KNN is got it. Can show like this, then display. So this is the accuracy of our model. As I said, there are different ways you can measure it. Let's see. So for instance here, we could use, another model. This was okay, nearest neighbors, okay? KNN classifier. We can do the same here. I'll just copy this one. And for regression, add another cell. Okay. So I'll just say, okay, I believe this can be cumbersome, just right. For regression, because it's logistic regression, just put this RR and then call the classifier logistic regression. And then I won't put any, I'll just accept the default parameters. And then I'll fit, oh, sorry. Dot fit method, I'll fit just the same text train and the Y train like this one. Okay, I'll predict, I'll say logistic regression predict equals to, I'll just say all right, dot predict. You're always predicting text, remember, like this one. Boom. Let's see the accuracy. I'll just come here and display the accuracy again. So I'll copy this one, display the accuracy of KNN. Now I'll just put the accuracy of logistic version is, I'll put accuracy score, but here I'll put a different model, which is pred, then run. Boom. Okay, so for this case, it tells us that the logistic regression is more accurate because it has like 97%, but this one only has 93% accuracy. Okay, you can always fix and trigger. So for instance, there is what we call a parameter tuning, okay? So for instance, here we say the number of neighbors were 3. So we just decided based on the 3 number of neighbors. What if we put maybe 5 number of neighbors and try to run this one? If I run this one, I see maybe you change anything. No, it doesn't. Okay, it doesn't have to, but sometimes it does. Just put 7 neighbors. Yeah, it says 0.9. It changes. It may not be always okay. Making change in the metric into maybe a different metric. Let's say Minkowski. I run it. I come here. 0.9. All right. So the classifier is not only measured in accuracy, but the accuracy just tells you how accurate your classifier is. And when you cover the confusion matrix, we just see the different kind of metrics, like the precision, the F1 score, I mean, the recall and everything. All right. Now, for the sake of this class, actually, we have discussed, I mean, what the scikit-learn is. You just seen we have used so many libraries. As I told you, it's very rich. And then what the data set is and what you can do with the data sets. We have worked with the iris data set, which actually is a simple data set to play with. You have different data sets. I mean, you can see how to split the data into training and testing and assign some of them in your model and then see how your model works. And you can play with some parameters just to change the results, see how it works. Maybe for instance, here we can just put 0.3. Okay. If you put 0.3 here, and you run this one here, and you try and run, okay, run this one too, and try and run this one here. You can see it is 9.1, and this one is, it is below. So you should know what is the best, what you actually want. And for the sake of classification tasks, this is how you can approach and you can use these kind of parameters to work with. We have worked with k-nearest neighbor classifier and the logistic regression, but there are so many differences. You can use the SVM, you can use the naive Bayes classifier, you can use decision tree, and there are so many differences, okay? So I just give you the homework. You remember, just work with different data sets. I mean, load digits, try to work on your own, improve your programming part, and just make sure that you can train your model and see if you can improve it, okay?